We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello everyone and welcome to the second video of physics. Myself PIYUSH and TANDEL, Assistant Professor of Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. In this session, we are going to derive the differential equation of simple harmonic motion. So before going on, we need to understand the basic of simple harmonic motion, right? So as we can see over here in figure, we have one bob, that is this metal ball, which is connected with the string with the fixed point, right? So if we are going to take this bob or take this ball at a point B, and then after we are going to release it, it is going to swing. So it is going to swing from the extreme point of B to the extreme point of C throughout the mean point. Over here A is the mean point, or we can say a steady state point where the bob is going to be at a rest condition. So this is also called as a mean position or center position, right? If we are going to observe this scenario from the top view, it is going to be look like this. So at a O, that is its equilibrium position, this is at a B extreme position, and this is at a C extreme position, right? So from this figure, we need to study about certain amount of things like time period, or second thing, that is more information like the position, the velocity, the acceleration with respect to the time. Then after third thing that we need to study, that is how much energy is spent to complete the one oscillation, right? So we need to study all these things in detail. So recalling the definition of simple harmonic motion, that is x is equal to a sine omega t. This is already we discussed in our first video. Now if we are going to differentiate this x with respect to time, it is going to be like dx by dt is equal to v, because change in displacement with respect to time, that is our velocity. So v is equal to a, and derivation of sine omega t, that is omega cos t. So omega cos omega t, right? Now if we are going to again differentiate that equation with respect to t, then it is going to be d square x by dt square, that is dv by dt. So change in velocity with respect to time, that is our acceleration. A is equal to minus of a omega square sine omega t, because the derivation of cos omega t, that is omega minus of omega sine omega t. So minus a omega square sine omega t. Now in this equation, as we can see that a sine omega t, this is the value of x. So from the equation number 1, x is equal to a sine omega t, we are going to put this value of x inside of this equation. So the value of acceleration a is equal to minus of omega square x. Give this the equation number 2. According to the Newton's second law, force is equal to mass into acceleration, and if we are going to find the value of acceleration, it is equal to F by m, or we can say force by mass. So now we are going to compare our equation number 2 with our equation number 3. So comparing equation 2 and 3, we get F by m is equal to minus of omega square x. From this equation, if we are going to bring our m on this side, F is equal to minus of m omega square x. But we know that force constant k is equal to m omega square. So putting the value of k into this equation, F is equal to minus of kx. Now give this the equation number 4. Now again recalling the second law of Newton, that is F is equal to ma. And as we all know, the derivation of velocity is equal to the acceleration. So dv by dt is equal to our acceleration. So putting the value of a is equal to dv by dt. Now again we know that the value of velocity is equal to dx by dt. So putting that value inside of the v, we are getting our equation F is equal to m d square x by dt. Now give this the equation number 5. So from our equation number 4 and 5, we can conclude some different thing, that is like from equation number 4 and 5, m is equal to d square x by dt. This is this term from the equation number 5 is equal to minus of kx, that is from the equation number 4. So d square x by dt square, bring this m on the right hand side, so minus of k by m into x. Now from this equation we can get omega square is equal to k by m. Simply that we are going to put the value of omega, that is k by m, into this equation. So we are getting our d square x by dt square is equal to minus of omega square x. Now bring this term to the left side. D square x by dt square plus omega square x is equal to 0. This is our differential equation of simple harmonic motion. I hope all of you are with your pen and paper and noting down each and every equation, so we can use this equation in further theories, right? So next we are going to study about velocity in simple harmonic motion. So we know that velocity is the distance per unit time, right? So we can obtain the expression for the velocity using the expression of the acceleration. So that is acceleration, that is a is equal to d square x by dt square, right? So again we can write like dv by dt, that is we already know. And again if we are going to differentiate with respect to the displacement, then we can write dv by dx into dx by dt. So what is the value of dx by dt? It is our v. So we can write the dx by dt is equal to v. So putting this value into this equation, we can get acceleration a is equal to v dv by dx. Now give this the equation number 6. Now again recalling the equation of simple harmonic motion, that is minus of omega square x, that we already derived in the first page, that is v dv by dx is equal to minus of omega square x. So bring this dx on the right hand side, v dv is equal to minus of omega square x into dx. After integrating both the side, we can write like integration of v dv is equal to integration of minus of omega square x dx. Now we all know the integration part, so minus of omega square x dx. Again integration of v, that is v square by 2, and integration of, that is x square by 2. So omega square is over here, so minus of omega square x square by 2 plus c. What is c over here? Where c is the constant of integration. Okay. Now to find the value of c, let us consider the boundary value condition. When a particle performing simple harmonic motion is at its extreme condition, displacement of the particle is maximum and velocity of that particle is going to be 0. So we can write like x is equal to plus or minus a. At extreme point, velocity is going to be 0, and 0 is equal to minus of omega square a square by 2 plus c. Now the value of c is going to be, c is equal to minus of omega square a square by 2. Now putting the value of c in this equation, we can get v square by 2 is equal to minus of omega square x square divided by 2 plus omega square a square by 2. This is the value of c. Again v square is equal to omega square in bracket a square minus x square. Now taking the square root of on the both side, we get our velocity equation of the simple harmonic motion, that is v is equal to plus or minus omega in the under root of a square minus x square. Now again we are going to study why velocity is going to be 0 at an extreme point. So we know that the velocity of a particle performing simple harmonic motion is given by v is equal to plus or minus omega under root of a square minus x square, that is we already derived, right? At a mean position, that is at the center position, x is going to be 0. The value of x is going to be 0. So we can write v is equal to plus or minus omega under root of a square minus 0 square, as the x value of x is equal to 0, is equal to plus or minus omega into under root of a square, is going to be equal to plus or minus omega into a. Now we can write like v max is equal to plus or minus omega into a, whatever the value of a, that is the extreme value. Okay. Now at the extreme point, that is x is equal to a, the value of x is going to be value of a. At that time what's going to be happen? Therefore v is equal to plus or minus omega under root of a square minus a square is equal to 0. So omega into 0 is equal to 0. So v mean is equal to 0. So we can conclude that at an extreme point this is at this point or this point, our velocity is going to be 0, and at a mean point the velocity is going to be maximum, right? I hope all of you are getting this equation and writing down in your notes. From this video, we successfully derived our differential equation of simple harmonic motion. Thank you.